Mr. Verghese Johns is an esteemed civil structural engineer with an impressive professional career spanning over 42 years, currently serving as the Vice President at Geostructurals Private Limited in Kochi, Kerala. He plays a key role in design and technical management of multi-story residential, commercial and industrial projects. Mr. Johns embarked on his career as civil engineer with HCC Limited in Bombay. He later gained valuable experience through his work with prominent organizations in Saudi Arabia, UAE and Qatar, including renowned consultants, oil and gas producing companies like Aramco and ADNOC and structural steel EPC companies. Since 2019, Mr. Johns has been a valuable asset to Geostructurals Limited Cochin, taking on the role of Vice President. He is a fellow member of the Institution of Engineering India and the Indian Association of Structural Engineers. Additionally, Mr. Johns holds the esteemed certification of professional engineer and is a member of American Society of Civil Engineers. He also serves as an advisor to various national and international organizations. I'm most pleased to welcome you, sir, to educate us with various concepts, benefits of off-site construction and modular building techniques.
Thank you for this wonderful introduction. Today I am really happy that to be here and then part of this presentation, this event. And the topic was, I'm going to present this prefab, precast and pre-engineered building. And the title, what is actually put it as the benefit of off-site construction and modular building techniques. So we are all aware that what is the current status of prefab and precast and pre-engineered and modular structures nowadays actually catching up in the market, and it is going to be the future as such. So when you start the definition of what is actually a off-site construction, is a construction procedure that involves planning, designing, fabrication, transportation, and fabricated building items and disassembling on the site with great speed and high degree of finish. The degree of precision as far as better than on-site construction. And off-site construction has elements that is componentized, panelized and modularized, which are used to perform as structural elements, enclosure and service elements as an interior partition system. This is what basically the all precast, prefab, pre-engineered and modular construction is nowadays is happening. So the most important component of this off-site construction is precast concrete. The precast concrete can be either we can call it as a ready-made concrete or prefabricated concrete. The form of construction is cast in reusable mold and then cured in a controlled environment. Precast plant is called precast concrete because it is a repetitive actually kind of construction procedure what we do for large number of buildings or structures or facilities. Then structural members as concrete frames, concrete walls and concrete floors can be constructed using precast concrete. Then prefabrication as defined will be done in 2 stages, manufacturing at factory condition and erection of components in the required location. So we can just have a look at it when this precast concrete has actually, when it was invented. And it is during the World War I. First, after that, a British city engineer, John Alexander Body, patented the process of constructing precast paneling building, because the war is always actually an initiative to develop engineering and development, because it's always actually by force. We used to have the engineering advancement. So they wanted to have to house the soldiers at site of the war zones. So they had to develop something as a precast building immediately constructed, like what we have sitting here in 2 days. This is constructed and we are housed so fast. This is the advantage of having a precast or a prefab construction methodology. Then we will go back to the history in India when it has started. The first time in Madras Port, precast piles retaining walls between 1905 and 1910, which is the first recorded pile foundation with precast in India. During the time of British, they actually did this Madras Port using precast piles. Then they actually formulated Precast Concrete Institute, PCI UK. And over a period of time that we also have developed the precast, not that early, but still recently we have established the precast and pre-stressed codes and standards also for design and implementation. That is, you can see that IS 15916, 15917, 11447, and National Building Code of India. That also explains and gives the requirements for precast construction and design. See, we can say what are the applications of precast and prefabricated system today. It is being used in most of the projects nowadays, partially or fully. So the precast pavements, septic tanks, drainage, this is all what we see daily. Somewhere you will see a precast when you go to a construction site or any part of construction. Prefabrication, industrial steel building, and pre-engineered building, PEB systems, steel bridges, pre-stressed bridges, culverts, precast foundations, footings, precast piles, storage tanks and concrete as well as steel, silos, pressure vessels, industrial structures, and so on. Modular construction, portable cabin, high-rise building forms using modular construction, railway sleepers and electric poles, and offshore platforms. Most of these applications are very big projects as well as very essential nowadays, that we have to have speed in construction and achieving the facility in operation, so that we spend less money, more economical and optimized type of construction. So if you come to precast concrete highway and railway bridges, then we know that high girders, pre-stressed reinforced concrete, steel plate girders and bridges, pre-stressed concrete segmental construction, pedestrian underpass, vehicle underpass. So there is a large amount of pre-stress and precast construction is required in the highways and railways nowadays. This is started a long time ago. That reduces the time and speedy construction and quality construction also. It is very well managed in a controlled construction or fabrication, so you can manage or maintain the quality as much as possible and best. So the India prefabricated building market growth trends and what happened actually Indian prefabricated building market is something in the range of USD 2.3 billion in the current year. So I'm anticipated to register a compound annual growth rate of 13% in the coming years. So the COVID-19 pandemic had caused massive disruption to the construction projects all over India. So most of the construction is actually in the very high pace, picking up to compensate what is actually lost and to catch up with the market share they lost. So the importance of precast and prefab is actually also becoming more prominent in doing that. So a big opportunity for prefab companies in India. and the hundreds of thousands of plants are expected to require in the future coming there. Unfortunately, the state which we are in, Kerala, is very little precast or prefab factories are here. So, but it is, I think it is going to happen in the coming years, or maybe it is going to, the need will force them to have something like that. And India is expected to become the third largest construction market in the world by 2025. So this is one thing which is going to have a very promising business opportunity for all the precast or maybe the fast construction, rather less, instead of going for conventional type of engineering or construction. So India's construction is expected to be US $1.4 trillion in 2025. That is what actually it is expected. So the urban population will contribute 75% of GDP, up from 63. So 68 cities will have populations over 1 million, up to 42 in 2021. India's construction industry is divided into 250 subsectors, well cross-sectional connections. In 2030, India's real estate industry is expected to be worth US $1 trillion. So contributing 13% of the country's GDP. So the construction industry is going to drive the economy of the country, so that how important this fast methodology or construction in the coming years. So we all know, we are all come from the engineering background and the construction background. We always say that if you talk to a contractor or anybody, that what is actually he faces, 15-25% materials are wasted, 25% of construction is rework, 30% of job site is unproductive, 40% of projects are over budget, 70% of projects are late. Quality is always an issue. These are the things what is actually in reality happening. How you can overcome these things when compared to a conventional type of construction? Or how this is also another forcing element to go forward for using precast or prefab construction. Then what are the advantages? Saves construction time and labor, quality assurance, use of pre-stressed concrete, cost effectiveness, durability, and aesthetic. You can get a very nice finish and color and other things when you don't have to do further painting or surface coating or anything you can achieve in the factory itself. So the safe construction platform, that is always done in a controlled environment inside a factory, so you don't have risk involved fatal risk involved like in a construction site. Shuttering and scaffolding is not necessary. This is one of the most expensive elements in a construction at site. So this can be eliminated or maybe avoided by having a precast construction. Installation of building services also is actually pre-designed, that is the only risk or maybe difficulty what we have. Everything has to be pre-designed, decided, so that you can put your services also, electrical conduits, holes for plumbing fixtures and other things has to be designed. You cannot do a on-site correction or modification as easily as what you do in the construction. That is comparatively, since we are doing a better planning and design and engineering, so we can do it. Then independent of weather conditions, most of the activities are inside a factory. So you don't depend on the monsoon or maybe the site problems. What you have, the labor agitations, you employ less labor force. Clean and dry work site, better housekeeping. So you don't dump waste. You will, like sir said, it is a lean kind of construction methodology, not waste is generated as such in the normal construction site. Possibility of alterations, reuse during precasting, that can be done during changes. Correct shape and dimensions and sharp edges are maintained because the finishing is comparatively much better in terms of you don't have to do an extra plaster. So that is also an advantage by doing a clearly and a good mold precast panel or a system. And so high initial investment, this is what the contractors are a little bit worried about, because to make this kind of facility, you have to have a initial investment setting up their factories, machineries and skilled laborers, skilled workers, technical people and so on. And you should have a continuous business also to continue with this. So that is where the problem arises. But once this methodology is applicable or come into the market in a standard way, or maybe in quantity, or maybe this will overcome, because there will be a continuous project, depends on what a factories actually can produce. Then transportation issue, that is another difficult thing because of the congested roads. You know what size of a module you will transport, what trailer you will take it. All these kind of problems are always, your length of the component will be restricted to maybe maximum 12 meters or less than that. Depends. And moving through the difficult, traffic, that is another biggest issue. So there are some limitations, but people are moving up to 18 meters in Cochin in the night. With special permission, you can do it, but not in the daytime or something. Then handling difficulties and so on, modification at site, it is difficult, sensitive connection works and things like that. So again, handling transportation, difficulty in connecting precast unit, produce some effect as monolithic, that I will talk little detail later. High transport costs, large heavier components, large site yard is required for storage at site, erection equipment, tower and mobile cranes, skilled labor and things of that. So where actually we are going to save cost in doing a precast? So it's basically on the wastage control, because the wastage production is minimized to the almost nil. Okay, there will be little, but not like an actual construction site. You create a lot of construction waste. And it is very difficult to remove, and health hazard and so many other risk hazard, everything is actually created that can be avoided. So that is one of the areas. The speed of the construction, maybe 1/3 or more than that can be saved by doing a precast construction. Quality is good, precast enhances safety. And virtually no repair or reworking cost, like what we have seen is more than 30% is rework at site. That doesn't happen. Stay established precast concrete means 23.22 cheaper, or some figures are there. It may vary. So these are some of the cost saving points. And this is a graph showing that material saved against in concrete and steel and manpower and wastage also, which is actually a tower graph which is showing something like that. And when you want to have a precast construction or a precast project, there are some barriers to precast concrete construction. Project delivery and supply chain, how you get your materials on, what are the requirements of how sequentially, like I said, just in time. Also, all these things we have to apply and get the materials on site for a fast kind of construction as the sequence of construction. And then design issues, awareness and knowledge, policies and regulation, and social climate and market demand. So these are some of I'm not going very detailed into it because of the time constraint. So the applications of pre-stressed precast concrete. This is one of the main advantages. Mostly that the L&T and all is doing a lot of pre-stressed girders. This is the advantage. You do it in a yard and then bring it to the site and install it. So there is a lot of advantages by doing building structures there, load balancing and all. You come with a very smaller sections if you do a pre-stressing and things like that. So larger spans and then reduce structural thickness, faster stripping time, reduce material cost, things of this kind. So now look at that, where are the applications of most of the precast, like culverts, building slabs, reservoirs or swimming pools, and retaining structures and bridges, box culverts and things like that, fencing. So these normally now we can see in most of the cities, the metro projects are actually, most of them are box girders. These are all precast things. How fast we are constructing these metros because of these facilities are available. Using this heavy cranes and everything is actually been done in no time. Kilometers, you do it in one day. So this is the concrete girder beam system that we have in KMRL, this system here, not the box girders. So like this precast segmental construction, this is just a picture of that. And then precast or prefabricated steel trusses with, these are all fast constructions. You know how long it will take to build a bridge like this in a normal way. So you do fabricate all these things at the yard with the design fast, and then fabricate it and bring and install it. It is become operational within no time. So this is what basically the public's projects or maybe the services what people can enjoy. Not like earlier days we take months and years to build a bridge. That time is over because of the precast and prefabrication system is available in there. So this is again like precasting of prestressed concrete girders. Also the road project. This is everything is actually precast here. So I just bring it and then construct and do it. And this is another thing which we are in the oil and gas energies. Most of the structure what is seen, the jacket as well as the top side, everything is precast or prefabricated in a yard, and then bring it to the offshore and then put it together and build it. So this is huge construction that is actually happening in precast or this is prefabrication like. So then we come to prefabricated steel structural building system. Now there is a lot of buildings, high-rise buildings are being constructed using steel structures, which is slowly picking up. But elsewhere in outside India, in mostly if you go to Middle East and all, the composite structures are in place maximum. So it reduces the space, faster construction, and then prefabrication is actually being done. Also the composite floor systems, steel building solution and things like that. This is actually Central Building Research Association actually preparing all this kind of innovative studies as well as recommending. Even the Transport Ministry also is actually been encouraging by issuing advices or orders to use more than 40% of precast element in their construction sequence. So these are all, government is actually encouraging this. And we also have to do it in private sector as well, so that fast construction can be done. And see, like this is some pictures. I am just doing a complete steel structure building, which is done in Panvel, Mumbai. This entire frame is actually steel structure. It won't take much time for erection or maybe at site. It's all prefabricated in a factory and then bring to the site and then done. So I may be from those who are coming from Calcutta, you have seen this building, best innovative steel design. The entire thing is actually a steel structure. And they are at Calcutta, the consultant was from Singapore. So this is, and they also won one of the best award for the building structures in 3 years ago. So this is something which is how a structural steel building will go in the sequence of what are the different types of building frame structure systems. And then these are lateral load assisting system for stability and all. We use a lot of moment connections, shear walls or bracing systems and things like that. It's all design concept adoption, what you can do. So this is a design of composite floor system, how you put your decks and shear studs and composite kind of succession, which reduces your thickness of the slab system, because if you go for a concrete beam, which will be much deeper, maybe up to 1 meter deep, and it will take a lot of space, and you don't have space sometimes crossing your services. AC ducts or maybe pipes or other things, because you lose. Suppose you are building a 20-story building and 1 meter you are deemed that you are losing 20 meters of space. So you can reduce that by using this composite floor system. So this is actually how it is actually been constructed, a deck system, and a concrete is being flowed. So this is the behavior of a composite, and the symbol, you can see that the stress diagram shows that how it will work together and independent, So this is also another steel building, because you can have very large spans. If you build a steel building, your column locations are maybe 10 meter, 15 meters and things like that, and nowadays you get hollow core slab up to 20 meters spanning. So you don't have much interference in space utilization, if you use. This is actually in Europe, people use this technology, and then most of the buildings are done steel structures, so that they don't have frequent columns and other things, in buildings like what we construct here. So this is one of the best advantage of having steel structures, prefabricated steel structures. So you can see that 9 to 10 meter in span, and you put 6 to 9 meter of precast or hollow core slabs. So you don't have much of an interference. You can have a large span building system. This also is another way you can do is the steel beams can be cut open for passing your services. These are castellated beams also available nowadays. So you can pass through all your things. So you reduce your waste space between the two floors. And it will be more, your supports are also, maybe these beams can support your services as well. So there is a lot of advantages by doing structure, floor systems and things like that. And these are all what I can say, bracing systems, what is required for a steel building. And these are all steel concrete composite structures, which nowadays most commonly used reinforced concrete inside a tube or a square hollow or a circular hollow, and sections of I sections or C section channels are also being used. So these are all, this improves the case of the slenderness and other things, the load bearing capacity of the sections comparatively much smaller, 50% of a concrete column. So this is something, a comparative study of RCC, steel and composite. What is the size of RCC that you reduce in steel and composite? How much space you can save by doing this type of a construction? So this is something, a comparative study actually conducted by some of the thesis or somewhere. So this is a cost evaluation, how actually the difference. Of course, the steel structure are costlier than RCC in the beginning. In some level, what is actually the biggest advantage is that you can finish the job maybe in 50% of the time. So your revenue start coming maybe much earlier than what you expected, and you can get a much faster quality product as well. So then now we comes to the one of the type of structure which is getting popular in our country, and that is PEB, pre-engineered buildings. So I know that you are all, most of the warehouses, storage, stores and other things, most of the people, even buildings also, they have started doing pre-engineered building system. What actually they do is they fabricate the sections from plates. welding the web to the flange, either in both sides or maybe sometimes in one side. That is one risk in there which people don't look into much detail. And they taper the frames. Like, you can see the section sizes are varying from the eave to the bottom because the envelope of bending moment, they cut save material there. That is how they do it. So this is various components of a pre-engineered building system. So you can see that this can be done, the erection can be done, or all the items are pre-fabricated from a factory and then bring to, say, within a month, or maybe the foundations are ready within a month, they can finish the warehouse or a storage yard. So this is the approach of pre-engineered building, how it is actually the stability approach, how it is actually being taken care of with the vertical as well as lateral and longitudinal directions. And this is the design criteria. I'm not going to explain in detail now, but this is the standard methodology what we apply for doing or designing a building. So these are the codes, the American, most of the PEB companies are using American code here. And they use something called a manual called MBMA, that is Metal Building Manufacturers Association. That is not a code, it's only a small guideline manual. And the loads, live loads and other things are recommended by IS 875 is not in line with this. They use a very low live load, under load and things like that. Is sometimes it's not acceptable to match with the Indian standard. That's why in PEB we don't have a code yet in IS. So we try to use the IS 800 2007, but it is little conservative because it is for heavy structural steel, not for light structural steel. So you can see that Zamil Steel is one of the PEB builder. They have done a high-rise building, Jeepus 11 commercial complex in New Delhi. So they do, see, these are the application: industrial building, indoor stadiums, parking lots, railway station, and so many places they use aircraft hammers. So they can do very large span buildings up to 40 meters, 50 meters and things like that. So it's all then metro stations, warehouse, high-rise buildings. So this is actually the way they fabricate pre-engineered building, the tapered sections based on the bending moment envelope. They cut and save a lot of material. So this is how it is actually differentiated between pre-engineered building versus conventional building. So this is actually the bending moment diagram which I am showing to show that how they arrive at this kind of a shaping. So it is a pin base and then a fixed base both. This is also another weight calculation for standard conventional steel and PEB as per 800 and as per MBA, how much difference it is actually coming in the steel weight. But I won't say it's a much saving, but we have to make sure that it is safely designed. Because the safety is one of the important things which we have to make sure that any code what we use, the designer has to be sure about what they are designing is safe. So this is the cost weight comparison of the steel. This is again cost. Okay, now let us talk about prefab and precast technology when it comes to concrete. So prefab technology is actually wise, eco-friendly, sustainable, time and cost saving, better quality control and proper strength. These are the elements which actually governing the prefab technology is catching up. So the technologies are formwork system, precast sandwich panel system, light gauge steel structural system, steel structural system, precast concrete construction system. So there's this different type of refabrication technologies implemented in there. And formwork system, there are different type of formworks, which is monolithic concrete construction, construction system, aluminium formwork, modular, caissons and seismometric technology. So these are all recommended by CSIR. So they recommend this kind of for systems which can implement in the precast or prefabrication. And this is precast sandwich panel system. And then now this is also catching up very much light gauge steel frame structures. These are also another type of prefabricated. Okay, this is fabricated and executed at site. This is how it is. But you can have the wall panel, roof panel, everything can be prefabricated and bring to the site and then do it. So benefit of precast, there are a lot of benefits. High quality, fire resistance, strength, and so on. There are so many advantages in doing, and then benefits also there. These are all different types of components of a precast. So this is how it is actually. So they are giving me a notice that I should cut short and do it. So let me jump. So these are all different these things. See, I just wanted to say something about the stability of the tall building system, how it is actually achieved in precast building. This is the most challenging thing in designing a precast high-rise building, because the most important thing is the connection design. So we have to failure corner columns or maybe facade column. So how many minutes more you are giving me? Finished? 10 minutes? Okay, so I have to conclude here. These are all different types of this thing. I will just pass through all because the subject topic is so big. You cannot just come touch the entire thing. People are building all this type of, these are all precast, prefab building systems. And this is one of the building, Instacon, Mohali, they have erected in 48 hours, precast building. Now, the recent development that we actually become one of the most populated country in the world. So what happens from China, shifting the world's to the center of gravity is shifted to India now. So this is the price, roti kapda or makan. You can see that what is the amount of money you need for housing purpose. In 2020 or 2040, the percentage is something in the range of 800%. So what we will do in problems, low cost housing. That is the only solution for this. And the government of India has actually developed so many yojanas by the Pradhan Mantri Yojana and all those things, which is actually capping up, which is mainly for precast. And now the Hindustan Prefab Limited, Government of India, that is started in India long time ago. So this is some kind of a construction projects can be more efficient and more faster or cheaper by doing project management technique, value engineering, then constructability, logic at site, then implementation of BIM, adoption of BIM technology in the construction management. So that is what is BIM and how it is actually, there are 8 dimensions of BIM, 1 to 8. And now BIM is going to be outdated very soon. It is going to be replaced with integrated collaboration platforms. That is another one more step ahead. So then end value management, these are all time and cost control in project management, and cost of and use of artificial intelligence in construction management. That also has been nowadays introduced. Then we didn't talk about modular construction. This is the last point of the presentation. Modular is actually another complete fabrication of your module as an apartment or maybe a house, and then take it to the site and install it. So this is the modern modular design concept. What is the size and other things are being decided based on the transportation. Then you design your modular system and then construct it and design it, then modeling and then bracing system. These are all LGSFS buildings constructed. Well, it is very important to bring sustainability into precast. How much sustainable it is going to be, the precast construction is considered as very sustainable. Development that meets the needs of a present without compromising the ability of future generations to meet their own needs. We do not inherit the earth from our parents, we borrow it from our children. Because we are borrowing everything what is reserved for them, we are stealing. So let us honor the debt. So these are all points which is required, buildings. This is actually a net zero construction. Then global this thing. And this is one point which I would like to say. Because of the global warming, there was a study conducted by National Institute of Oceanography. They found that if the water level increases in Cochin in the coming years, something in the range of 598 square kilometer sea level, the area of Cochin will be underwater. So this is a very alarming situation. Then what civil engineering can do for this? What I would like to conclude with, we are the first generation to feel the sting of climate change, and we are the last generation that we can do something about it. Because this is associated with the prefab and other things, which more than 25 to 40% of carbon emissions can be controlled in doing prefab and precast. Thank you.
Thank you, sir, for your words of wisdom on off-site construction and its benefits, highlighting the impact of COVID-19 on the prefabricated buildings market in India and so on. Now, I would like to invite Mr. C. Gauridasan Nair and Mr. Nebu Abraham to present the memento to Mr. Verghese Jones.